All right, hi class, welcome back. This is part 2, looking at task 2 and picking up where we left off with your t-test. So we did t-test looking at whether or not there was a significant difference between male and female school-aged children on weekly pedometer steps. And I left you with the task of creating a graph. There's just a few things that I wanted to show you in case you were struggling. So one thing that I found really easy was just to make this a 2x2 table. Well, this is 2x3 table, but ignoring the p-value here. Mean and standard deviation, and then male and female. Just selecting here, making a graph, or making these this bar chart here, or column chart. In order to get the error bars on, I just want you to notice that the male error bars is quite large compared to the female error bar, and you can check this. You look at the standard deviation of the male data and it's over 26,000 steps versus the female data, which is over 12,000 steps. So the male standard deviation is more than double that of the female. So this makes sense. This looks proportionately correct. So some of you might be struggling every time you go to, say, you right click on your columns here and you want to format your data series to add the error bars. When you go to select a standard deviation, it wants to continuously update so that the male and the female, or these two columns of data, have the same error. Well, they clearly don't, right? You've calculated that. So going into custom, we're going to use our own calculated standard deviations. And it's handy that they're set up this way, because what I'll do is I will just select these two cells. So hold down and drag, select, and the same thing. So the negative value is the same, right? Select, and OK. Shouldn't change anything because, right? All right, and so if you were having trouble with that, every time you tried to, say, hand pick the male standard deviation, it was constantly updating the female, then that will solve that problem. Okay. All right, so let's move on to task 2 of your homework assignment. Task 2. So we want to find out if there are differences in weekly step counts in school-aged children of different sexes and from different regions. So we're going to choose the appropriate statistical test. You'll report your means and standard deviations. Of course, you're going to graph your findings. And if you did not find a significant difference, we may be able to collapse our data. So we ran a t-test and we didn't see a difference between males and females. So we're going to go ahead and run a different statistical test and confirm that. And if it does turn out that there is no significant difference, rather than having 50 participants per each group, now we can have 100. And this essentially makes our data more normal. Okay. And then we're going to run some follow-up statistical tests. We're going to run follow-up t-tests to identify which specific groups were significant, or where were the differences, or where are the differences. Okay. So let's go to our data here. So I've just made a copy of our data. Okay, so going back and looking at the appendix in your assignment, just to make sure we are choosing the appropriate test, we have more than 2 groups, right? So we have we have at least 2 nominal variables. We have gender and region. We have males and females, but then we have 3 regions that we're working with. So we're going to run a 2-way ANOVA to look at significant main effects. The first one of gender in steps and region in steps. And then we'll see if there is a significant interaction between gender and region. Okay, so this is, again, from your inferential statistics cheat sheet that I had given you in class one day. So for you Stats Plus or Mac users, it's going to be quite simple. So you'll select your Statistics tab, going into Analysis of Variance, a 2-way ANOVA, Your response or dependent variable is the weekly pedometer steps. So highlight and select the arrow to drag it into the box. And factor 1, we're just going to use gender. It does not matter which order you put these in. And factor 2, region. This is just the order I'm happening to use. I don't know if that's how to say that. Anyway, we're going to go ahead and keep this as fixed. Keep these unchecked. And when you hit OK, a whole new worksheet's going to pop up. And you can see that it's giving me a nice little table here looking at if there is a significant main effect of gender on weekly steps. There is not. So our alpha level was set to 0.05, and you can see that this is greater than that or exceeds that, and so it is not significant. Let's look at region. That does appear to be significant. So 0.002 is significant. So there does seem to be a significant main effect of region on weekly pedometer steps. And then is there a significant interaction between gender and region? No. So 0.105 is definitely larger than our alpha of 0.05. So here is where our significant main effect is. It's within region. Okay. So for you PC users using the data analysis tool pack, it's not as easy. So we're going to have to do a little organizing before you can run your statistical analysis. So what I've done here is I've created this 2x3 table looking at so regions by sex, right? Male, and then scrolling, and female. So here within these columns are all of my weekly step counts. So region 1 males, region 2 males, etc. Okay, so when it does come time to run your analyses, you don't want to just select the columns, right? Because Excel is going to go looking, it's wanting to reference specific rows, and you have all of these empty rows at the bottom of your worksheet here. So by doing that, that would not be a good idea. So you're going to have to actually select just this box of data, and you'll scroll all the way down. Okay, no more, no less. Right, so let's look. I've done a few screenshots of what that's going to look like. So you'll go to your data tab, you'll go to data analysis, and you will select an ANOVA 2-factor with replication. Select OK, and it will provide you with this screen. You'll highlight this little chart here. It'll allow you to select your input range for the whole box of data. You have 50 participants per group per sex, an alpha level of 0.05. I like a new worksheet. It usually just inserts it right in front of your current worksheet. Okay, and then select OK. And what you end up with is something that looks like this. Okay. So it provides you a nice little summary. Of course, this is my doing here, so but nice little summary here, and then the results from your ANOVA. And you can see that here we have a significant main effect, region and weekly pedometer steps. All right, so I've asked you to graph your data, and I think it's very easy. I'll just do this, deleted that, to make a table. So, knowing what I know that region 1 is North America, region 2, Europe, and Asia. I've just made a table of all of my averages, and you're going to want to probably do this for your standard deviations as well. But I'm just going to show you how easy it is to make a chart from this neat data table, neat and tidy data table. So just highlight it first, go up to Insert, Chart. So rather than having to select, there you go, you're done. That's it. Okay, so then you'll go through and you'll do your error bars. But that's essentially it right there. Okay, it's a nice little chart. You can see there does seem to be something happening in Europe. But, our results said that there was no significant main effect of gender, but, definitely something appears to be happening over here. But there is your graph. Okay. So on your assignment, I have said that we didn't have a significant main effect of gender on our t-tests. We also didn't see a significant main effect. There was no significant difference when we ran our t-test of gender, and there was not a significant main effect of gender/sex on weekly pedometer steps when we ran the two-way ANOVA. So because of that, we can go ahead and collapse our data. So rather than having 50 participants per group, we can have 100 participants. And what this does is it actually creates an even more normal distribution. Okay. So looking at that collapsed sample, and we can collapse the sample and we can follow up, or just if you're curious, you can always run a one-way ANOVA, because now we have essentially one dependent variable, which is weekly pedometer steps, and 3 different groups, right? Students just fall into one of 3 regions. So we can run a one-way ANOVA, and then your data, very close p-value here, this 0.0023, it's just slightly larger, but significant, right? So there's a significant main effect of region, and gender doesn't seem to influence that. So I'm going to leave that up to you as far as, I think the graph that I showed you with males and females is very interesting, but you can always graph your collapsed sample a little differently. Let's see here. All right, so I've just gone ahead and I've graphed it using a bar chart. So I've just selected my means here. And, we have Asia and Europe and North America. So what I really need to do is I need to follow up with some statistical tests, because graphically speaking, I can see that Asia and Europe are pretty close and North America is trailing way behind. And so I want to run some t-tests to see if, in fact, North America is significantly different than Europe and significantly different than Asia. So, looking at that, nope, okay. I have another sheet here that we're going to use to make sure. Okay. And so what I've done is I just copied that table, that 2x3 table that I made for the analysis tool pack. It's right here, but I'm not going to necessarily worry about sex over here. I'm just going to focus on regions. And I have, you see I have here region 1 compared with 2, 1 and 3, and 2 and 3. And just running the t-test, you can see my formula right here, just selecting region 1, region 2, 2 tails, okay, 2 tails, and then the 2 stands for independent samples. Okay, and you can see that I have a significant difference between North America and Europe and North America and Asia, but when I compare Asia to Europe, I do not have a significant difference. So it's nice to be able to confirm that statistically and then go ahead and identify that on the graph. So you'll see in some scientific publications, to denote significance, just to make sure that your reader is really picking up what you're putting down, we can just insert maybe a little asterisk. Let's see here. Just even a little text box. And this really can get absolutely infuriating. So just keep that in mind. You're not alone. So asterisks work pretty good, but getting it to stay where you want it to stay and not move. I've seen students actually take to printing it out and drawing a symbol. I don't think you'll have that much trouble, but it can get a little irritating. So just a little asterisk maybe over North America, denoting that it's significantly different than both Europe and Asia. And then of course nothing on Europe and Asia. And I just like this bar chart because it looks like a race. We're losing. Definitely losing. Okay. But you'll put your error bars here, and usually the asterisks just will go right above the error bar, and then you'll, in your comments on the bottom, if I were to say, let's do another one. You'll do this in a Word document, but just for, so here's my figure, weekly pedometer steps of school-age children, type like that. From Asia, Europe, and North America, and then you write in a little, asterisk denotes significance, and then you would put your P is less than 0.05 and call it good. So you do that in your Word document. Okay, I hope that's very helpful. We are going to move on. So let me make sure that covers all of task 2. Yep, it looks like it. So we got to collapse our data. You're going to go ahead and graph your findings, looking at, I guess, by gender or sex. And actually, I'm going to have you graph this new finding. Actually, let me just say here, this new data set. I'm not sure how to word that. There you go. And then you'll run follow-up statistical tests, and then that should cover it. Okay, I better save that. All right, so then next video, we're going to look at task 3, and this is creating a frequency distribution just to look at the normal distribution of your data and how increasing that sample size essentially made the data look a lot more normally distributed. All right, that's it. Thank you.